I have timbre. So timbre, what is timbre? It's it's that's an aptitude to auditory systems, auditory sensation in terms with no, it's not good. What is timbre? This sense of hearing, the aspect of sensation by which two sounds with the same loudness, pitch, duration, and ear can of presentation can be distinguished, even if the same loudness, pitch, and duration. Timbre is often used to refer to the sensations associated with the envelopes, but also temporal factors are included. Timbre often refer to the quality of a sound. The definitions of a timbre. There are three definitions according to Monasu. There is a timbre, identity, that means same group, character of the auditory sensation that enables the recognition of belonging to a category, source category. Which source category we hear? So we have timbre, individuality. That means character of the auditory sensation that enables the recognition of belonging to a given source. You can find the given source. And then the third, timbre, quality. The third one, character of the auditory sensations that differentiates two sounds of the same pitch, loudness, localization, and duration. Even if it has same loudness, pitch, and durations, localization, it's mainly spectral. There's three: spectral sensory, impulsiveness, and spectral spread. Okay. Timbre identity, to find if some music instruments same category or they have the same source, or the quality, the spectral, you can find it even more close. Spectral sensory, same as brightness, impulsiveness. That's about something about the speed, and spectral spread fluctuations. Timbre, you can use measure timbre the same way as you find cities on the map on for instance in the United States, relationships for the cities. We have some here, and yeah. So we have some we can also make investigations about ask people about differences between countries. For instance, the United States and Cuba, they seems very different in people's opinion, even if they're geographically very close. Timbre space. So we have dimension 1 is dim 1, impulsiveness. Dimension 2, I write it like here, this way, dimension 2, it should be brightness, and it could and lower to higher, low, high, and impulsiveness, longer and shorter could be. Then we have dimension 3. It is fluctuation, less, greater. And the instruments in those 3 dimensions. Yes, we have some temporal descriptors. Temporal descriptors. It could be like for the impulsiveness, it's called log LAT. It's about it's log 10 of t end minus t start, I think, like this. It's a log, so we have here some energy, and we have here some sound, and I think t end is about the 80% here, 80% minus, I think it's 10% and 80%. I think it was like that. No, 20. So the time difference is 20 here. The time difference is this. Let me take the logarithm. LAT, we have this minus that is not very robust because for some sounds the maximum is not located at the end. That could be a problem. End of the sound, attack. So, but it could be a measure for impulsiveness. So then there's impulsiveness, another. It should be T1 divided by T2. So we have a graph here. Yes, here is T2, and here is T1. Is 10% of Amax. Here is 40% Amax. Not very good figure, but it's okay. Yeah. So yes, we have a temporal envelope here. So T2 is more than 10%, and T1 is more than 40%. This fraction gives the impulsiveness. Yes. Okay. And then we have some SC. This is spectrum centroid, and I think it's like this. Some sigma k times ak times f0, the fundamental frequency, like this. And you can calculate it. There are some examples here. And an example of this, but I will not use time on it. And the next one, SC for brightness, how bright it is. Yeah. Then the spectral spread. It should be some I think it's like f minus sc squared times those amplitude. Yeah, some statistics. So there are three spectrums with same centroid, but different spread. We know it from the statistic. Different spread. Yeah. And so yes, and then we have some other um, yeah, this spectral centroid, it's you can just it's just to it's a middle value, mean value, and this is first. I think it's called the first moment, and is spectral spread is the second moment. Yeah. Okay. And then we have some. Yeah, I think I will soon stop. There's some noisiness. It's about ratio between total energy minus harmonics, where the harmonics is something about, yeah, those amplitudes squared. Yeah, and we can also have some roughness. So, and then I can say the most loud sound we have here graph, here 100, we have this threshold, at 1000 hertz. We have the SPL here in 1000 hertz. The SPL value and the phone value is the same. Yeah. Most sensitive 124 kilohertz. Okay. And I say thank you.